Today's video is about the order of operations and the properties of equality, and really how both of these things help us solve equations for things we don't know their values. Our learning target is I can use the order of operations to help me solve equations, and I can explain why the properties of equality help me while solving equations. So the first thing that I want to bring out is the order of operations. Please excuse my dear Aunt Sally. Those are parentheses. Okay, there's all sorts of parentheses. There's some that just look like that. The absolute value symbols are also parentheses. There are brackets of all sizes and shapes. Okay, all sorts of them, and they can be nestled within each other. But what the grouping symbols really do for us, or these sets of parentheses, is tell us, hey, start here. This is where I need you to begin. The E stands for exponents. That's any number that's raised to any power. If you have anything like 2 to the third power, they really want you to simplify what is 2 times 2 times 2 and rewrite it as one term of, not 6. Why is it not 6? If you need help with that, please ask Miss Maury tomorrow. She can figure it out with you. However, 2 times 2 is 4. 4 times 2 is actually 8. Okay, I put multiplication and division on the same level because we always do multiplication in order from left to right if there's more than one set of multiplication or division in a problem. The same with adding and subtraction. We always go from left to right. So let's talk about this problem right here. 10 times 2 divided by 5. Okay. Fraction bars are really just undone division problems. So this bar actually means to divide. The entire fraction bar goes across the 10 and the 2, which really means I could rewrite it as 10 times 2 in parentheses divided by 5. So because I have some parentheses there, it says to start here. So I have to figure out what 10 times 2 is. That's 20. And then I divide 20 by 5, and I get 4. So let's go back to our order of operations here. I started first with the parentheses. Within the parentheses, I did my multiplication. Once I got the answer to that problem, I actually did the division that was involved with it. The same thing would happen here if I had 10 plus 2 divided by 4. Even though division is higher up on the order of operations, meaning I should start there, because this fraction bar goes all the way across, I'm actually grouping it together. So I should actually start by adding 2 first to get 12, and then do 12 divided by 4, which is actually 3. So it's really important to notice the order of operations, and it's the order in which we solve a problem if everything is known to us. Let's move on. Why do we care about equality? Equality is really important because we do the order of operations to maintain equality so that we can say this expression is equal to this. So let's try this. We have 5 plus 2. What is that equal to? Give me the equation. Hopefully you said 5 plus 2 is 7. Okay? It's equal. This side of the equation is equivalent to this side. If I was to add 2 to this side, would that still be equal? Hopefully you said no, because now this side is actually equal to 9. However, if I added 2 to this side, would that still be equal? In fact, it would. It would stay 9 is equal to 9. So let me recap here. I added a 2 to both sides of my equation, and that kept it equal. It's the property of equality of addition. Adding something to both sides keeps things equal. Let's try this. Would it still work if I subtracted from both sides? So if I subtract 3, it's really important that I pay attention to where I write my minus 3 on this side. I could either do 9 minus 3, which I'm going to go ahead and show that because that's the typical way that we think about subtraction. If I put it out here, it wouldn't have worked exactly the same. If you don't understand that, please come see Miss Morey, she'll help out. However, I get 6 is equal to 6. I'm keeping things equal. Let's try it with the multiplication. If I multiply, whoa, sorry, I didn't mean to do that. If I multiply by 2 and I multiply by 2, do things stay equal? I think they're 12 is equal to 12. I'm keeping my equality, property of equality of multiplication. Let's try dividing. What if I divide this side by 2? I would also have to divide this side by 2 to get 6 is equal to 6. So the statement is, as long as I do something to one side, if I do the exact same thing to the other, I keep my equality. The equal sign is a very important symbol in mathematics. How do the order of operations help me to keep expressions equal? Okay, this has something a little bit to do with what happens when I don't know what a number is. So I'm going to give us an example. What if I have 2 times some number, I'm not quite sure what it is, plus 3 is equal to 9? Okay, we can kind of think through this logically. That's kind of like saying something plus 3 is equal to 9. So what would that something need to be? Many of you are pretty good at saying, well, oh, hey, I know it would be 6 plus 3 is equal to 9. Is that true? 6, 7, 8, 9. Oh, it is. So the question is, if I have 2 of those unknown somethings, what would each of those somethings be? So that plus that, because it's multiplication, which is repeated addition. So what would those 2 somethings be? And hopefully you just said 3 plus 3 plus 3 is equal to 9. I'm keeping my equality. However, what happens if I didn't know that? Or if my numbers were harder than just really easy whole numbers? So let's talk about that. The first thing I'm going to do is ask myself, what if I knew what x was? And let's pretend like x is equal to 1. I know that x is not equal to 1 because we just figured out it was 3, but let's try it. I could then rewrite this side of the equation as 2 times 1 plus 3. With the order of operations, what operation would I do first? Would I multiply first or would I add first? Please excuse my dear Aunt Sally. Hopefully you just said that I would multiply first. So I would multiply, that is a horrible M, sorry, and then I would add. Okay, that's the order that I would do the operations if I was told what x was. The problem is that I don't know what x is, so I have to work backwards and from the opposite direction. It's kind of like as if you were trying to trace a map backwards. If I told you to head out of my classroom and take a right, and take another right and walk down the hallway, you would end up kind of near the library, sort of. You can kind of think about that. If I asked you to go back to my room, I would have to walk in the opposite direction, right? Because I'd be going backwards. And instead of turning right, I would have to turn left each time. So I would actually be doing the opposite thing. So because I don't know what x is here, I have to do the opposite thing in order to work backwards. So if this is what I would have done first and this is what I would have done second, I need to now do the opposite thing. So the opposite thing of adding is subtracting and the opposite thing of multiplying is dividing. But I have to do them in the reversed order. So I'd have to do this first and I would have to do this one second. The key is to ask myself, what do I do first? What do I subtract first? I subtract the thing that was added above. So I'm going to subtract 3. And to keep everything equal, I have to subtract 3 from that side. I'm going to move my stuff over here because I just ran out of room. So I get 2x, a positive 3, and a negative 3 when combined is 0. I don't need to write that. And a 9 minus 3 is 6. So check. I'm going to just draw a big check mark. I've done it. I've subtracted. Now I need to divide. I divide by 2 because I was multiplying by 2. I show that with a fraction bar because that's really just a division problem. So 2 divided by 2 is actually 1. So I'm left with 1x is equal to 6 divided by 2 is 3. So the order of operations helps us decide what do we do in order to solve a problem. So I knew if I knew what x was, I would first multiply and then add 3. So to undo that, I'm actually going to subtract 3 and divide by 2. I can always check to see if I'm right by resubstituting in 3 to my equation, and it turns out I'd get the right thing. Let's try a little bit harder of a problem. Okay. What if I have 10 plus x, that whole thing divided by 2, is equal to 6? I'll ask myself, if I knew what x was, let's say, I'm going to draw a little line. Let's say x was 5. Okay, let's make it 6. I would have 10 plus 6 divided by 2. What would be my first operation here? Hopefully you identified that this is kind of like grouping symbols. So it would be 10 plus 6 is 16 divided by 2, which ends up being 8. I think my first thing to do, and I'm going to write that right here, was to add. I added 6. Then my next thing was to divide by 2. So if I use that, when I do my order of operations in the reverse order, I'm actually going to subtract and multiply, but I'm going to move in the opposite direction. So here I did this first and that second. Now I'm going to do this first and that second. So I do it by what I was. What was I dividing by over here? I was dividing by 2, so now I'm going to multiply by 2. Let's look at what happens when I do that. I'm pretty sure that that cancels out with that. If you don't know why, please come see Miss Maury in the morning. It's easy to help you with that. But if I multiplied this side by 2, I have to also multiply this side by 2. So I'm pretty sure I get 10 plus x is equal to 12. So I've multiplied. Now I need to subtract. What am I going to subtract? I'm going to subtract the thing that I was adding by. And in this case, I was adding 10 to the x. So I'm going to subtract 10, and I'm going to subtract 10. Okay, 10 minus 10 is 0, so I'm just left with x, it happens to be a positive x, plus, is equal to 2. So that means if I was to substitute into this original equation a 2, I would get 10 plus 2 divided by 2. That should equal 6. Order of operations. This fraction bar is showing me I need to divide everything that's there by 2. So 10 plus 2 is 12 divided by 2 is 6. So in fact it works. All right. I hope that helped. Here we learned how we can use the order of operations to guide us in how to solve equations. We also learned about the properties of equality, which means that if we do something to one side of our expression, then we have to do that same thing on the other side of the expression in order to keep things equal.